Hey guys, and welcome back. So let's continue now. I'm gonna create a wrangle node. I'm gonna call this curve mult, and it's equal to v at cd.x. I'm gonna store this, or let's call this path mult. Okay, I'm gonna use reset the color. We've stored this information if we wanted to use it as a multiplier. Now, another thing that is very important when we look at the geometry, we don't want the emission to be, we don't want the smoke to be coming off everywhere. If we go, let me turn this off. So this is our geometry, and let's say this block of geometry here, we want to emit smoke from that, and in reality it's going to be only emitting smoke from behind. Anything in front, we're not going to see smoke coming off of here. And the way we're going to separate this is by using the velocity information. So if we take a look at the velocity of the geometry, you see it's facing this way, and what we can do is we can do a cross product between the normal of the geometry and the velocity. So if we let's put down a facet node and let's compute the velocity, the normals. So if we look at the normals, see these normals are facing this way. They are closer to the velocity alignment. These normals are are completely in the opposite direction. And if we run a cross product between the two, it's going to give us a very nice mask that we can use. So let's let me turn back the points, and let's make sure we have a normal information on the geometry. So if we look at the points now, see we have points, we have the normals, and we have the velocity. Let's create a point fop, and let's do a dot product between n and v, and let's plug that into the color information. And look at that, we have a white mask where things are facing in front and black where things are facing backwards. So let's inverse this. Sorry, I'm gonna negate the velocity, or we can do it in many different ways, but I'm gonna negate the velocity, so everything that is behind now is gonna be used as an emitter. And this, look, it's working perfectly with everything. So if we step through, we're not gonna get any front emission. And what I'm gonna do is I'm gonna blast and delete anything that is black. Okay, so I deleted all the points, and this is only the parts that are facing away from the geometry. Okay, and the next thing is we want to, let's do this here. So we have that information, the normalized path as well information, and we can use that as a multiplier. And then the last thing we want to do is we want to compute the length of velocity. Let's create a point fop, and so every time I'm deleting points, and let's create a length attribute, length. Let's compute the length of the velocity, and I'm going to fit range this. And this is, I'm going to use only pieces that are moving. If it's static over its lifetime, we don't want to care about that. So let's set this to 2 and 10. And if anything is constant and it's not moving, then it's gonna be colored in a different with a darker tone, and then everything else is going to be white. So we can use this as a separation, and let's be a bit more aggressive. 15. And now I'm gonna also delete anything that is not moving, and we're getting almost there. And we can add the mult as well here. So let's bind import, what did we call it, path mult, I think. me check the name. It's path mult. Let's check this. Okay. And I'm going to use this as a multiplier on top of the velocity as well. And we're going to connect this. And if we delete now, should have a very nice emitter that shows us only the pieces that are moving, that are facing, the points that are facing in the right direction, and then we are not getting anything that is very far away from the source based on the path. And the last thing is we want to do a trail. This is the trick. And with this trail, check something super quick. So I'm gonna trail the geometry 6 times, and this should give me back a copy of the geometry or the points over the previous frames, over the previous 6 frames. And then I can use an add node and say I want to connect all the points. And let's make sure we have an attribute, a point attribute. So here, let's do that here. I call this ID, or PT is equal at PTNum. And then we're going to use that attribute to connect with. So now we should get a set of curves for each emission. Let's go to a different frame. And this is our geometry, original points. We trail them back using a trail node, and then we connect them. And so we have multiple points filling in the space. I'm going to do a resample to increase the number of points. It's a lot, so let's do 0.25. And then I'm going to use a VDB from particles. And I'm going to increase this to 1. It's too big. Let's try 0.1. And now this is going to convert the points into a VDB. And I'm going to use density. I don't need an SDF. And I'm going to lower the point radius as well as the minimum radius. So let's lower this to 1.5, and this is 2.1. And now we have a very nice emission. And with this technique, with this trail technique, we're going to have a continuous emission. We don't have to do any substepping. Okay. And that's the geometry we're going to use to emit from. And that's pretty much it for this video. Let's continue in the next one. See you guys, and thanks for watching. Bye bye.